And how do we expect the result?
For which one? Interpolate? For interpolate?
Let us, for interpolate.
Multilinear Lagrange interpolation.
Multilinear. Like, what are we passing in? And how do we expect the output?
So you choose your representation, right? Maybe dense sparse or the third one that we shall not name. Then you pick points. You're going to pass in points, right? So your points must have the
tuple and
maybe, for example, that's one way. Okay. But if you know that it's always sequential, you might omit the Boolean hypercube, right? You just pass in the y values. Then the person that's doing interpolation will know that the first one is 0, 0, the second one is 0, 1, 1, 0, 1, 1. So there are different ways to do it.
Then the output should be
your representation. Yes, but in your representation. It's like univariate.
Like for this one, right? We were able to multiply the coefficients by 2 because both of them have. But then maybe while iterating, that means you have to look into the tuple of exponents first of all.
To know whether it exists.
Yes, if it is a 0, you pass.
Yes.
But if it is a 1, you multiply the
coefficient
by that value. Then minus that one from the cell.
Exactly.
You get 0.
So Rahima has told us how to do partial evaluate. Okay? For sparse. So the way you do it is you are going to be told B, right, is equal to 2. Then B has a position, right? So in this case now, B is always like this guy here, right? The middle guy, index 1 of your tuple.
Yeah.
So let's say you could be told evaluate at index 1, evaluate 2 at index 1, rather than B, right? You just put the index directly. So what you do is you iterate over the array. Then you check the tuple. Is that index on? If the index is on, then it means that there was a B in that monomial, right? So you multiply this value with the coefficient. Then you change the B to 0 because it's no longer there. Do you get what I mean?
Yeah.
So if you have something like 3AB, right? And you evaluate B equals 2, then you will get what? 6A. Does it make sense?
Yeah.
So this is how you do it in sparse.
But since like evaluating in sparse is more straightforward, do we really need partial evaluation in sparse?
So for some check, you need partial evaluation. You are never going to evaluate everything at once. You'll be evaluating one by one. So for your polynomials, you need partial evaluation and you need evaluate. Evaluate can be written using partial evaluate. Like you just, let's say you're supposed to evaluate A, B, C. You can just partially evaluate A, then partially evaluate B, then partially evaluate C. Then you get your results. So that's one way to do it. Yeah, so partial evaluate, once you can figure out partial evaluate, you have figured out evaluate. Yeah.
So, the multilinear transformation.
Yeah.
Can we use it?
Yes. So multilinear polynomial is a linear function, right? Yes. So do you want to use it to implement evaluate?
Like
partial evaluate?
Yes.
You want to break it?
Yes.
How will you separate it?
I don't know yet.
So when you separate it, what will it look like? Like, will you have something like just A? There's something like just B?
No linear independence. Where something is linear independence.
What does that mean?
We have a basis. So I will use that to separate it.
So will A, B, C be your basis?
Yes, something
like there's independency between the two then. That's what I was talking about, that you factor it out, then you have like a polynomial.
For A, for B, and for C. So just try it. Try it on paper. Then let's see. Let's see if it works. So what I'm thinking now is that we should stop here, right? Why are you laughing? Wait, no. So if we stop here, that's not all. Then we go home,
Oh, that's one assignment.
Which assignment?
You should go and do effort.
No, that one is just a test. That one is just a test. Wait.
It's up to you, right?
It's not. This one not really an assignment. This one is more like try. So try and figure out how to do. Not code though, just like algorithmic. It's for sparse.
Do what?
So sparse and dense. Yeah, sparse and dense. Just try to figure out how to do partial evaluate. That's all. You just partial evaluate. Wait, is that all? Will you partial evaluate? I'm coming. No, don't code it, oh, please, oh. Don't code it yet. This is not the third way. If you want to, you can code it. Yeah, but this is not the third way. I think it's just partial evaluate. So the actual assignment, since Rima has already told us how to do it for sparse, so everybody should forget sparse now.
Please tell us again.
Yeah, but it works. What you suggested works.
You need to figure it out.
Let me over the sparse out. That will be a side quest.
Eh?
The sparse implementation.
No, don't implement it.
No, like the sparse explanation.
Oh, we should do the algorithm. Okay. But wait, let me first give you what I want to give you. So.
No, if you tell us, you cannot give us also.
Wait. You want me to forget, are we? So, it's only partial evaluate. Evaluate. Yeah, but we don't. They're giving clues. Huh? Okay. Yeah, so just partial evaluate, right? Yeah, so just try and design a sparse representation and the algorithm for partially evaluating it. Then design a dense representation and the algorithm for representing it. So we already saw that dense had like two different representations, right? There was the ones that they came up with where they rewrote the Boolean hypercube, so they shuffle things around. And there's the other one where you just follow alphabetically, right? But there are more. There might be more. So if someone can come up with something more interesting. So tomorrow we'll just talk about that. Then we'll now talk about like how to actually, one way to do it. So we'll go over one way to do it. But for you guys should ever try. Yeah. I'll do it outside.
Okay, so I'm trying to remember what brought us to partial evaluation. We were trying to.
So someone gave a way to do dense evaluation. Then I was not like, once they try to do partial evaluation, it will be difficult. So that's why I brought up partial evaluation. But it's used for some check. Okay. So now let's do partial evaluation for sparse. Okay. So this 2a plus 3b, we want to evaluate it at, let's say c equals 3, right? So c is going to be equal to 3. So the sparse, this thing is this, right? 2, and this might not be the only way to represent sparse. Like someone can figure out a different way to represent sparse. Maybe you realize that there's something we're doing that is too slow. Maybe before we can figure out that there's b in this, it's taking too long, right? Someone can figure out a different way. So just play with it a bit, right? So when we say that evaluate c at 3, we're going to say c, let's say the index of c. So the index of c is what? It's 2, right? So evaluate at like 2, 0, where 2 here means c, right? So that's we're checking, we care about the second location in the tuple when you are indexing from 0, right? So 0, 1, 2. So now you only want to multiply this value, this is the value, with the coefficients when there's actually a c there, right? And we already know when there is a c.
That if the value is not 0.
Yes, if c is not 0, right? So those are like selectors, they turn it on or off. Okay, so now we check the first one, right? There is no c here, so we don't do anything to this. We just rewrite it. Right? but the other one there is a C. So we multiply the value, the coefficient. So C is equal to 2, so multiply 3 by 2, which is equal to what? 6. But now there's no longer C, right? So that means we are flipping. Does it make sense? Yeah, right. And yes, C is 3. Yeah, right. So that's 9, right?
Yes, that's
Thank you for paying attention. So 9. Does it make sense? It does?
So it is necessary for us not to just impute all the figures and get it at once, but we should get it one after the other.
You're saying that partial evaluation has a use case, right? Imputing all at once is evaluate.
Yes.
Putting one by one is partial evaluate. There are some cases where you want to partially evaluate, but you don't want to evaluate. So you need that method in your polynomial, partial evaluate. We didn't need it in univariate because there's no way to partially evaluate in univariate. There's always full evaluation because it's just one variable.
But with partial evaluation, not make it slow.
Depends on your implementation, right? But it's not slow. You mean like, are you saying that if you are partially evaluating a full evaluation, it might be slower? That's true. Does it make sense?
So after admin now, we still have like it's another form.
What do you mean?
We haven't made any changes apart from moving that there.
Yes.
So I think the idea of doing that is to say that is simpler form.
Yes. So a two variable system.
Disappear.
A two variable system, right? Instead of a one variable system.
How do you convert it to that?
Yes, so you could, so you have to be careful here now, right? Because so what it's saying now is that you can just delete the last index. So it now becomes right? They are rewriting it. So we called it relabeling. Right, like so now this is a smaller polynomial. Right? This is 2ab plus 9b. Right? So this works. But then you have to be careful, right? What if you evaluated b? You get so the real polynomial was ABC. We evaluated b, right? This is b. Right? But if you had deleted this, are you seeing where I'm getting to? So let's say I now deleted the b value, right? So that'll be 1, 0. And this will be 0, 1, right? So are you going to call it, is this, there's no more c, right? I don't know if you get what I mean.
Well, what do you need it for?
You don't need the label. What do you mean? Let's start again, right? Let's evaluate this. Want to evaluate this at what? At b equals 2, right? So we're checking this index, the b index. It exists in both, so we're going to multiply, right? So that'll be what? We're multiplying by 2, right? So that's 4, 1, 0, 0. Then right? But then we want to now delete the b, right? Yes. No, see, we're evaluating at b now. Yes. So we want to delete b. So we're deleting this, and we're deleting this. So that will now be what? 4, 1, 0, and 6, 0, 1. Now, what is this polynomial? If you just looked at this, you will get something different, right? It will be what? 4a plus 6b, right? If you just look at this. But given the context of where we're coming from, you know that, oh, that was c, and then we deleted it. So it's now like, but it doesn't matter the naming, right? Technically, it doesn't matter. Like whether it's A or B or C, it doesn't matter. So it's still fine to leave it 4A plus 6B.
Or can we change to like start some latter on so that it's still aligned? Because
Yeah, but you can't choose. You can't choose the order that they will as a partially evaluate.
yeah.
So what for you guys? All you just care about is you don't care about the naming of the letters, right? You just delete it. No, you leave it the way it is. Then you have another function called. This is all not necessary when we go to where we want you guys to get to. So this is just for context. Yeah, this is just for context.
When we do this,
Yeah.
we
Yeah, we also appreciate. Yeah, that's why I'm putting you guys through this pain, so that you can appreciate the other one.
Yeah.
Alright.
But that makes sense now. So just try and design your dense and sparse reps. Try and design your dense and sparse reps. So.
Try.
Okay.
Try.
Alright, we're done.
We're done.
Yeah.
Chow time.
Next time.
Yes,